Hey everyone, and welcome to my DeFi. So this is a detailed video about the STEMI and why there is a change. There is the change that we see in the STEMI. Why they are happening? What's the reason behind it? So this guy here is the reason behind all changes that can be seen in the STEMI. And before discussing about this guy, let's first discuss about the normal ECG. So this is the normal ECG, and the first part here denotes the calibration. The calibration is set to be 0.5 volt to 1 volt. Okay, it can be changed by the machine. The second part here is the first upward deflection, that is P wave. After that there is a downward deflection, that is Q wave, then upward deflection, that is R wave, and the downward deflection following R wave is the S wave. After that, the last deflection, that is mostly upward, is the T wave. So you can see our series on the ECG basics to know more about these, and there are more detailed videos about the ECG. In this video we will be focusing on this STEMI. So let's see what this guy do to change this this normal ECG in the STEMI. So the first thing here it does is it depresses the normal PQ segment below the isoelectric line, but this change is normally unseen, and it gives us a relative look that ST segment is more elevated than the normal. The second thing it does is it prolongs the Q wave. And the final thing is the elevation of the ST segment. Hey man, hey, where are you going? Yeah, you. Tell me, what are you? What is the reason behind all these things? So before discussing the reason, let's discuss what is normal. So here is the heart, and here is our lead. Our lead, if I zoom and this part of the heart, I can see here is the septal wall and here is the ventricular wall. So in the septal wall, the depolarization wave is going in this direction, that is opposite to the lead, and that gives us the Q wave. And in the ventricular wall, the direction of the vector is towards the lead, that gives us the R wave. Now because of the damage of the myocardial tissue, this myocardial tissue sends a depolarization wave that is against the direction of the normal lead. Now because of this, and this is the reason behind two things happening there. The first thing that was happening is a PQ wave, PQ segment depression, and the second one is the ST segment elevation. Both of these things are because of this abnormal vector that is thrown away from the normal direction by this damaged myocardial tissue. Now the second thing that happens here is this myocardial tissue that is damaged makes an isoelectric window, and because of this isoelectric window, our lead notes the depolarization vector of the septum more than the normal, and this is the reason behind the abnormally downwards Q wave. Okay, more downwards Q wave. This is the reason. So that was the two reasons, or I can say most accepted theory behind the STEMI changes that can be seen. There are several theories that you can find on web, and you should go and check out them also. So that was all about the STEMI part, and thanks for hearing me.